Welcome to ExpressRoute. Welcome to our comprehensive guide on implementing Azure ExpressRoute with private peering. I'm excited to walk you through this foundational Azure networking service. ExpressRoute is one of Azure's most powerful networking features, and today we're focusing on the most common scenario, private peering. This is what most organizations start with when they want to connect their on-premises infrastructure to Azure. In this presentation, we'll build a complete ExpressRoute connection from scratch using Azure CLI commands. By the end, you'll have a working private connection between your corporate network and Azure Virtual Networks. We'll cover everything from the initial planning phase through the final verification steps, including real-world tips I've learned from implementing these connections for enterprises. Understanding the architecture. Let me explain what we are building today. This diagram shows the complete ExpressRoute private peering architecture that we will implement. On the left, we have your corporate network. This could be your headquarters, data center, or any on-premises location. Your router connects to a connectivity provider, like Equinix or Verizon. The magic happens in the middle, the ExpressRoute circuit. This is a dedicated connection that never touches the public internet. Microsoft's Enterprise Edge routers connect directly to your provider's network through their MPLS or Ethernet infrastructure. On the Azure side, we have the ExpressRoute gateway acting as the entry point into your virtual network. This gateway is what we will spend considerable time configuring properly. The beauty of this design is that your traffic flows over private IP addresses through dedicated infrastructure, giving you predictable performance and enhanced security. Prerequisites and planning. Before we dive into the implementation, let's talk about what you need to have ready. Getting these prerequisites right will save you hours of troubleshooting later. First, you need an active Azure subscription with the right permissions. You'll need network contributor access at minimum, but I recommend contributor or owner for this lab. For the connectivity provider, you need to choose someone like Equinix, Verizon, or AT&T. Each has different peering locations, so pick one close to your physical location for the best performance. The IP address planning is crucial. You need non-overlapping address spaces between your on-premises network and Azure. Also, you'll need specific /30 subnets for the BGP peering. These are just for the routers to talk to each other. Finally, make sure you understand the costs involved. ExpressRoute circuits are billed monthly regardless of usage, so plan your bandwidth accordingly. We're using 1 gigabit per second in this example, which is perfect for most enterprise starting points. Creating the foundation. Let's start building. The first step is always creating a resource group. I know it seems basic, but choosing the right location and naming convention here sets the tone for your entire ExpressRoute implementation. I'm using East US 2 as our region. This is where our ExpressRoute gateway will be deployed later. The resource group name follows a clear pattern. RG ExpressRoute Basic tells us exactly what this contains. This command is simple, but it's creating the logical container that will hold all our ExpressRoute resources. Everything we create next, the circuit, gateway, virtual network, will live in this resource group. Pro tip: always include environment tags from the beginning. In production, you'll want tags for cost center, environment, project, and owner. This makes cost tracking and resource management much easier later. Now we're creating the heart of our ExpressRoute connection, the circuit itself. This command looks complex, but every parameter serves an important purpose. The peering location, Silicon Valley, is where Microsoft's equipment physically connects to your provider's equipment. This needs to match where your provider can deliver connectivity. We're choosing 1 gigabit per second bandwidth. This is the dedicated bandwidth you're purchasing. Unlike internet connections, this is guaranteed bandwidth that's always available. The SKU family, metered data, means you pay per gigabyte transferred. For predictable workloads, unlimited data might be more cost-effective, but metered is perfect for getting started. Standard tier is sufficient for basic private peering. You only need premium if you want global reach or connections to multiple regions, which we'll cover in advanced scenarios. Once this command completes, you'll have a circuit in a not provisioned state. That's normal. Your connectivity provider needs to provision their side before it becomes active. Next, we'll discuss the service key and provider coordination. Here's a critical step that trips up many first-time ExpressRoute implementers. The service key is like a unique identifier you give to your connectivity provider. This key tells your provider exactly which Microsoft circuit to connect to. Without it, they can't provision their side of the connection. The key is a long string. You'll typically open a ticket with your provider and include this service key along with your bandwidth requirements and peering location preferences. The provider coordination can take anywhere from a few days to several weeks, depending on whether they need to run new fiber or if they have existing infrastructure at your location. Start this process early. While your provider is working on their side, you can continue building the Azure infrastructure. The two work streams run in parallel. Now, we're configuring the BGP peering session. This is where the real networking magic happens. BGP is the protocol that routers use to exchange routing information. The peer ASN 65001 is a private ASN that represents your organization. Private ASNs are in the range 64512 to 65534, and you can choose any available number. This identifies your network to Microsoft's routers. Those /30 subnets are crucial. Each provides exactly 4 IP addresses. 2 go to Microsoft's routers, 2 go to your routers. The primary and secondary subnets provide redundancy. VLANID 100 tags the traffic for this peering session. If you later add Microsoft peering, it would use a different VLANID like 200. The shared key provides MD5 authentication for the BGP session. While optional, I always recommend using it for security. Make it complex but memorable for your network team. After this command succeeds, you'll have a peering session in provisioned state, ready to advertise routes once your provider completes their provisioning. Virtual network architecture. Now we're building the Azure side of our connection. The virtual network design is critical for a scalable ExpressRoute implementation. I'm using 10.2.0.0/16 for our virtual network. This gives us 65,536 IP addresses to work with. Make sure this doesn't overlap with your on-premises networks. The gateway subnet is special. It must be named exactly Gateway Subnet, which is an Azure requirement, and it's where our ExpressRoute gateway will live. I'm using a /24 which provides 254 usable IPs, more than enough for gateway instances. The 3 workload subnets represent a typical 3-tier application architecture: web tier, application tier, and database tier. This separation provides security boundaries and allows for different network policies per tier. Pro tip: always size your subnets larger than you think you'll need. It's impossible to expand a subnet after creation, so plan for growth from the beginning. ExpressRoute Gateway Deep Dive. The ExpressRoute Gateway is arguably the most important component we will deploy. This is what connects your virtual network to the ExpressRoute circuit. First, we need a public IP address. Despite being called public, this IP is only used for the control plane. Your data traffic still flows privately through ExpressRoute. The ERGW1AZSKU provides zone-redundant deployment across availability zones. This means if an entire Azure AZ fails, your gateway remains operational. The 1 indicates 1 gigabits per second performance scale. Gateway deployment takes 20 to 45 minutes. This is normal. Azure is provisioning redundant virtual machines behind the scenes. The no wait flag lets our script continue while the gateway deploys in the background. While we wait, you could continue with other tasks or grab a coffee. I usually use this time to double-check our IP address planning and review the provider's provisioning status. Connecting everything together. This is the point where everything comes together. We are creating the logical connection between our ExpressRoute circuit and the virtual network gateway. The connection name, Con-er to Hub Basic, follows a clear naming pattern. This is helpful when you have multiple connections later. Notice how we reference the ExpressRoute circuit using its full ARM resource ID. This is the definitive way to reference Azure resources across subscriptions or resource groups. The routing weight of 100 becomes important when you have multiple ExpressRoute circuits. Higher weights are preferred, so if you add a secondary circuit later, you might give it weight 50 for backup purposes. Once this connection is established and your provider completes their provisioning, you will have end-to-end connectivity between your on-premises network and Azure virtual machines using private IP addresses. The connection typically shows as connected within minutes of both sides being properly configured. If it stays in the connecting state, usually the issue is on the provider side or with BGP configuration. Okay. Let's move on to verification and testing. Now comes the exciting part. Verifying that our ExpressRoute connection is working properly. These commands will help you confirm that everything is functioning as expected. The first command checks the overall circuit status. You want to see circuit provisioning state as enabled and service provider provisioning state as provisioned. If the service provider state shows not provisioned, your provider hasn't completed their work yet. The BGP peering status is crucial. Both primary and secondary BGP sessions should show as connected. If they're showing connecting or disconnected, there might be an issue with your BGP configuration or routing. The effective routes command is my favorite troubleshooting tool. It shows you exactly what routes the ExpressRoute gateway has learned from your on-premises network. You should see your on-premises networks, like 10.1.0.0/16, appearing with a source of virtual network gateway. Pro tip: if you're not seeing your on-premises routes, check that your on-premises router is properly advertising them via BGP to Microsoft's routers. Traffic flow and route analysis. Understanding how traffic flows through your ExpressRoute connection is critical for troubleshooting and optimization. This diagram shows the complete traffic path from end to end. Notice how traffic flows from your on-premises VM through your corporate router, then through the ExpressRoute circuit to Microsoft's Edge routers, and finally through the ExpressRoute gateway to reach Azure vMIS. The return path is equally important. Azure vMIS send traffic back through the same ExpressRoute gateway, but they choose the path based on route preferences and BGP attributes. Route tables play a crucial role here. The ExpressRoute gateway automatically creates routes for your on-premises networks in Azure route tables. Similarly, your on-premises routers learn about Azure network ranges through BGP when troubleshooting connectivity issues. Always trace the path in both directions. I've seen many cases where traffic works one way but not the other due to asymmetric routing or firewall rules. Monitoring and performance. Monitoring your ExpressRoute connection is essential for maintaining optimal performance and catching issues before they impact users. Azure provides several built-in tools for this. Network Watcher is your primary tool for connectivity testing and troubleshooting. The Connection Troubleshoot feature can test reachability between your Azure VMS and on-premises resources. Azure Monitor metrics give you visibility into circuit utilization, BGP session health, and gateway performance. I always set up alerts for BGP availability. If it drops below 100%, you know there's an issue. Log Analytics integration captures detailed logs from your ExpressRoute gateway. This is invaluable for troubleshooting intermittent connectivity issues or understanding traffic patterns. Remember to establish performance baselines. You should establish baseline metrics for latency and throughput when the connection is working well. This makes it much easier to identify performance degradation later. Troubleshooting common issues. Let me share some of the most common ExpressRoute issues I've encountered and how to resolve them. These troubleshooting steps can save you hours of frustration. The circuit not provisioned error is usually straightforward. It means your connectivity provider hasn't completed their provisioning. Contact them with your service key and ask for a status update. BGP session issues are trickier. If your BGP sessions show Connecting, instead of connected. Check your peer ASN, VLAN configuration, and shared key. Also verify that your on-premises router is configured with the correct IP addresses. Root advertisement problems often stem from incorrect BGP configuration on the customer side. Make sure your on-premises router is advertising the correct network prefixes to Microsoft. Performance issues can be caused by suboptimal routing, MTU mismatches, or bandwidth limitations. Always test with tools like iPerf to isolate whether the issue is with the ExpressRoute circuit or your application. Remember, Microsoft support can see their side of the connection, but they can't see your on-premises configuration. Come prepared with logs and configuration details. Security is paramount when implementing ExpressRoute. While the connection itself is private, you still need to implement proper security controls to protect your environment. Network security groups should be your first line of defense. Apply NSGs to every subnet containing vMIS, and follow the principle of least privilege. Only allow the specific ports and protocols that are actually needed. Route filtering is critical, especially if you plan to add Microsoft peering later. Always use route filters to control which services are accessible through ExpressRoute. Azure Firewall provides centralized security for your hub and spoke architecture. It can inspect and control traffic flowing between on-premises and Azure, as well as between different Azure virtual networks. Consider implementing Azure DDoS protection standard for your public IP addresses, even though most traffic flows privately through ExpressRoute. Don't forget about monitoring and logging. Enable NSG flow logs and Azure Firewall logs to maintain visibility into your network traffic patterns and potential security incidents. Cost optimization strategies. Let's talk about cost optimization strategies for ExpressRoute, which can be expensive if not managed properly. These strategies can save your organization significant money. The circuit cost table shows the monthly charges for different bandwidth options. Notice how the cost per Mbps decreases as you go higher in bandwidth. This is important for planning your capacity. Start with the minimum bandwidth you need, and scale up gradually. You can increase bandwidth easily, but decreasing requires creating a new circuit. Monitor your utilization regularly to right-size your circuit. The choice between metered and unlimited data plans depends on your usage patterns. If you transfer more than 1 TB per month, unlimited usually becomes more cost-effective. Consider ExpressRoute Local for workloads that only need connectivity to the local Azure region. It's significantly cheaper than standard circuits and perfect for many scenarios. Use reserved instances for ExpressRoute circuits if you're committed to using them for a year or more. The savings can be substantial, up to 20% for one-year reservations. Performance optimization. Now let's talk about getting the best performance from your ExpressRoute connection. Small configuration changes can make a huge difference in real-world performance. MTU optimization is often overlooked but critical. The default MTU for ExpressRoute is 1,500 bytes, but you might need to adjust this based on your on-premises network configuration to avoid fragmentation. BGP optimization can significantly improve convergence times. Consider adjusting BGP timers and implementing BFD, or bidirectional forwarding detection, for faster failure detection. For high-performance scenarios, consider upgrading to an ERGW3AAZ gateway which supports FastPath. FastPath can reduce latency by 2 to 4 milliseconds by bypassing the gateway for data plane traffic. Proximity placement groups can reduce latency between your vMIS and the ExpressRoute gateway. This is especially important for latency-sensitive applications, like trading systems or real-time analytics. Don't forget about application-level optimizations. Things like connection pooling, caching, and efficient data serialization can have more impact than network optimizations in many scenarios. Summary and next steps. Congratulations! You've successfully implemented a complete ExpressRoute connection with private peering. This is a significant achievement that provides the foundation for secure, high-performance hybrid cloud connectivity. Let's recap what we've accomplished. We created an ExpressRoute circuit, configured private peering with proper BGP settings, deployed a zone-redundant ExpressRoute gateway, and established end-to-end connectivity between on-premises and Azure. You now have private IP connectivity between your corporate network and Azure Virtual Networks, with predictable performance and enhanced security compared to internet-based connections. For next steps, consider implementing redundancy with a second ExpressRoute circuit, adding Microsoft peering for Office 365 connectivity, or exploring global reach for connecting multiple on-premises locations. The monitoring and security practices we discussed will help you maintain this connection effectively. Remember to regularly review your bandwidth utilization and costs to optimize your ExpressRoute investment. Most importantly, you now have the foundation knowledge to implement more advanced ExpressRoute scenarios like FastPath, ExpressRoute Direct, or complex hub and spoke architectures. Well done!